Is JavaScript truly a single-threaded language? Well, it is, but it has some multi-threaded behaviors which might make you think it's a multi-threaded language. And I'm going to explain how that works. Now, when we talk about threads, you can think of threads as basically a worker or something that can perform tasks. A single-threaded language like JavaScript has just one worker doing all the tasks one after the other. For example, if you look at a code like this, you have this task, you have this task, you have this task. In a single-threaded language, this runs, then this runs. Then we have this function definition which is saved in memory. Then we have the function execution, and this another task performed on that same thread. When you think about multi-threaded languages, they have multiple workers that can perform tasks, and languages that have this multi-threaded feature support running multiple tasks simultaneously. So when you look at a code like this, for example, while one thread is running this task, another thread can be running this task at the same time. Now, JavaScript by definition and even by design is single-threaded, which means one worker doing every task one after the other. But when you think of asynchronous operations, like with your timers or event listeners or your web requests, it begins to look like JavaScript can do multiple things at the same time, but that is not very accurate. And this is where the browser exposes features that makes JavaScript look like a multi-threaded language, even though it's actually a single-threaded language. So single thread, one thing after the other, we have this, we have this, we have this, we have this function definition. Now let's say I put this down here after this set timeout. This set timeout, we have this callback function running after 1 second. If I come here now and I refresh, you can see we have running first operation, running second operation, running third operation, running fourth operation, and then after 1 second we have running timeout operation. If I refresh this again, you can see after 1 second this comes up. So even though the timeout operation was defined here, this function was still executed before this callback function ran. That's why we have running fourth operation, and then we have the running timeout operation. Now this might look like JavaScript is using multiple threads to do multiple things, but that's not what's happening. Instead, what is happening here is when the JavaScript engine comes across a line like this, it hands it over to the browser, which you can say the browser runs on a different thread, and when that operation is completed, in this case it's a timer, in another case it might be an event list, now it might be a web request. When that is completed, it now comes back to the main thread that JavaScript is running on. Here is a good way to visualize this. So you have the call stack, which is the main thread where JavaScript runs one thing after the other, and you have an event loop, and you have a callback queue, and then somewhere down here you have web APIs. These web APIs are like your timers, your fetch requests, or even web workers. Now, when you have a web API like our timer, the JavaScript engine is going to hand off this operation to the browser to run it. So this operation is not running on the main thread. Same thing with the event listeners and the web request. It is running on a separate thread provided by the browser, not by JavaScript. Now, while that is running here, JavaScript continues with the other things in the call stack. For example, these are function execution and every other thing that comes afterwards. Now, when that operation in the web API is completed, the callback function will be added to the callback queue. In this case, we have this callback function. In a fetch request, we have a callback function like this. For your event listener, you have a callback function like this. It sends that to the callback queue, and then you have this event loop which checks if anything is running on the call stack, and if there is nothing, it takes what you have in the callback queue and puts it on the call stack. So at the end of the day, you still have just one main thread that the JavaScript functions or code or whatever is being run on, but you have other threads or other running processes which is provided by the browser, not JavaScript. And this is also the same thing with workers. So in JavaScript, you can create workers. The idea is that they can run simultaneously while your main code is running. So here we create a new worker and we have this worker file here. And this might also look like you have a multi-threading going on. Well, the idea of workers is to give you something like a multi-threaded behavior, but it doesn't make JavaScript a multi-threaded language. Now, in this case of workers, this is again provided by the browser, and it allows you to have a separate other thread. But the difference between this thread and the main thread is that they do not share the same memory. In an actual multi-threaded language, multiple threads have access to the same shared memory. They can access the same data. But in case of JavaScript, you have just the main thread, and you have this other thread provided by the browser. And if this thread has to communicate with the main thread, it uses messages. For example, here we have worker.post message. So we're sending a message to that thread, and then here we listen for messages coming from the worker, coming from the other thread. So here when we post this message, this worker can listen to the message here. We have message from main thread and we have the data, and then when we get the message from the main thread, we can now send the result back to the main thread. So this way we're able to hand off certain processes that might take some time to a separate thread so that JavaScript can continue with the main thread until that process is ready. Now we look at this here. When I refresh, you see we have first operation, second operation, third operation, fourth operation, then the message from the main thread. So even though here we actually have the fourth operation running last, because this again is handed over to the web APIs, a separate thread to be processed, JavaScript continues with this. Then we post the message to the worker. Here we receive the message and we log it. So message from main thread, hello worker, and then this posts a message back to the main thread. On the main thread we can listen to the message. We have message from worker, hello worker, and then we have the timeout operation, which is run after 1 second. If I should change this to 0 seconds and I refresh this, you see we have the timeout operation running after the fourth operation, because this timeout operation was handed to the browser to complete, and during that time JavaScript continued with other things, so it ran the fourth operation. That's why we have fourth operation. Then the timeout is ready, we have the timeout operation, and then we have the message to the worker and from the worker. So while all of this might look like JavaScript is running things on multiple threads, no, by design JavaScript is single threaded. You have just one main thread doing the main task. But with the help of the browser, you can have other threads running by the side, either with the help of web APIs like timers and web requests, or workers which do not have access to the same memory. But then when they are done running their task, they still have to come back to the main thread to continue where they stop, either with the callback function or with the received message. So JavaScript is truly single threaded. The browser just makes it look like it is a multi-threaded language. If you enjoyed this video, please give it a like and subscribe for more web dev explanations like this.